Hi there. Thanks for stopping by for another look at the idun cartridge for the Commodore 128. So one of the aspirations for this cartridge has been to make use of all of the features of the Commodore 128. And not just use them in a checklist sense, but use them in ways that improves the user experience and the programming experience compared to what we've had in the past with the C128 or compared to what's possible with the more limited hardware of a C64. So up until this point, there's been something decidedly missing from that, and that's the Z80 CPU, which has been just sadly dormant, unused, unloved. But now, with the latest release, there's a way to actually wake up the Z80 and do something with it. So I'm using the screencast method and demoing this in the emulator, but we're connected on the back end to an actual idun cartridge. So everything I'm demonstrating is possible on the actual hardware, and if you stick around to the end of the video, I'll run these programs on my actual 128D as well. But we're here at the boot screen for idun, and I'm going to do a really quick demonstration of how the Z80 is woken up by the new release. So if we just hit return and then type the DOS command, then we'll launch into the idun shell. And once in the shell, we're going to cd to the idun base directory, and there's a new Z80 subdirectory now that's included with the standard distribution. And type directory there, you'll see that we have some source code, and we have something called alive, this 32K binary. And then if we just type the command zload alive, hit return, and here we see what's actually the output of a Z80 program, drawing some colorful text on the 40-column display and playing a digi sample on the SID. Press any key and we're right back into the idun shell. So what we've done here with the zload command, and I'll show it again real quick, is we've started from the idun shell running on the 6502, obviously, and we've switched modes to the Z80, run a program that we've loaded, and then press any key, which the Z80 program is waiting for a key press, and we're immediately dropped right back into the idun shell. So let's see that again. So obviously zload is a new command that makes it possible to run Z80 programs from the idun shell. Very simple usage, just provide the name of the program. Wake up the Z80. If we type help zload, you'll see a little bit more details about how it works. And it tells you here in the help file that the Z80 code is loaded into RAM bank 1 and has access to the full 64K in that bank. So that's how it's able to run a Z80 program without disturbing what's happening on the 6502 side, where the idun shell and kernel and all the other code is running within RAM bank 0. So the program file specified as argument to this command must be a valid Z80 binary as built by the ZCC cross-compiler and assembler. So what is ZCC? Well, that's the other very important part of this. Here we have a new repo within the idun project on GitHub known as idun-zcc. And this is a Z80 C compiler, assembler, and library for making C128 Z80 mode programs on the idun cartridge, meaning you can build them directly on the idun cartridge. So this idun-zcc is a package that's installed by default and is based on the Z88DK project. So that's where the compiler tools, the assembler tools, all of this comes from. Additionally, there was a C128 compatible library that's part of that project, and I've simply modified it, patched it, so that it works with the idun cartridge. So if you want to learn more about how to use CCC and how to make use of and contribute to the C128 library, this would be the repository that you want to take a look at. So ZCC is installed on the cartridge by default, and the way you can make use of it is just press F7 in the shell to jump into the Linux terminal, and we see we have a source code subdirectory, and there's some sample programs here. So, and there's a make file as well. So if you just type make, it will automatically invoke for you the ZCC compiler and build the sample applications. And again, this is all happening on the actual idun cartridge. So if I just, before I leave the shell here, if I type the inxi command, you'll see that the machine we're actually running on here is a quad-core ARM v7 Raspberry Pi 02. And then if we type directory, we'll see we have some new Z80 binaries, and we can run those again with the zload command. So let's do this ANSI test one first. And this is just using the 40-column screen again to do basically a simple hello world type of application, draw some colored text on the VIC screen. And press return, exit back to the shell. But what does the source code actually look like for these Z80 programs? So let's use the idun file browser to actually take a look at the source code. So we'll log in and navigate once again to idun base and the new Z80 subdirectory. There's our programs that we just built, and here's the source code. So let's take a look at ANSI-test.c, the program we just ran. And you can see in the file browser you actually get color syntax highlighted C code, and this is the entirety of that ANSI test program. And as you can see, it's just a string of printf commands, output text to the screen, and each string has regular text as well as these ANSI escape codes to create the different colors and styles. And also to draw the X, there's some code at the bottom here. Cursor position test uses ANSI escape codes to position the cursor to certain locations, and that's how it can draw an X on the screen. So very straightforward C code that you compile with CCC, and then you have your Z80 application ready to run. We can also take a look at the alive.c program. So this one you saw was kind of large. It was 32K, and the reason it's 32K is because 28K of that is just taken up by this digi file. And then here's the entirety of the code for that program. As you can see, it draws some text on the screen. In this case, not using ANSI escape codes, but using C functions like goToXY and text color and printf once again. And then there's a high-level C function, play ZB4SID, that will play this digi sample over this on the SID chip. And that's the entire program. So pretty short and sweet. So both those programs were obviously designed to use the VIC2's output and 40-column mode, but of course we can also make use of the VDC. So let's take a look at draw80.c for an example of something that would run on the VDC. And this actually uses bitmap display mode. So here's the entire program right here. It initializes a bitmap display to be 640 by 200, and then it uses these high-level C functions like line VDC and ellipse VDC to display graphics in the 80 column mode. So to see what that looks like, back in the idun shell, we'll use the mode 80 command to switch into 80 column mode. And of course we have to change the emulator to the VDC display. And then we'll do a Z-load draw 80. And just that quick, you're into your Z80 program that we just compiled, and it's drawing lines and ellipses. And pressing the key, we're dropped right back into the 80 column idun shell. We also have a version of Alive for the 80 column display, so we'll do Z-load Alive 80 this time. Basically the same program as Alive 40, slight difference using different C-level function, high-level functions to draw on the VDC's display. And one last example program to demo. We need to jump back into the 40 column display. And we're going to run Death Star or D-Star. So this is a little game that was actually ported over from Z80 based Texas Instruments calculators. It's been around for quite a long time. It's one of the favorite demos of that Z88 development kit, Z88 DK project. And here we have it running on the VIC-2. So the way you control your little ball here, it's a puzzle game basically. You use Q and A for up and down and the O and P keys for left and right. And you can move your sprite around to try to absorb all these little bubbles on the screen. And when you've successfully gotten rid of all of them, you advance to the next level. And there's like 25 levels to this game. And there you're at the next level. So what's neat about this is obviously you can do graphics. So this is VIC-2 character mode graphics, and doesn't use any hardware sprites or anything. It's just character graphics. And if we take a look at the code for this, so we'll open up the dstar.c file, and this is by far the most complicated C code that we've seen so far. I mean, it's a game, you would expect that. But a couple interesting things I want to point out about it. First of all, right here at the top of the main, you see this alt P D018, a value of 8A. So this is basically the C equivalent of a poke command. And what it's doing is it's putting the VIC-2 into a mode where we can use character generator RAM at address 2800. So VIC-2 is, the text display is at address 2000 hex. At 2800, we've just told it we're going to place some custom character graphics. And then you see this little loop below there where it just loops 128 times and copies something into this UDG array. So very simple little C loop. What is that doing? If we close this window and we open instead the dstar.h file, you'll see that defined in here we have this character array called UDG at address 2800 hex. So basically what it's doing in that loop is it's loading data, which is defined in here, all these def-b binary data statements that are defining our sprites. And we're saying that we have this UDG array that's created at address 2800, which matches where the VIC-2 address is going to look for its custom character set. So that simple loop basically sets up all the sprites graphics we need to then be able to display the game board. So now for a final demonstration, let's see how all this looks running on real hardware. So there we have real proof of life. The Z80 lives. Thanks for watching.